Well, here we're talking about the review for the factoring chapter, and the first couple of problems, what we're going to be doing is finding the prime factorization. And number one, when you have a negative number, remember the first thing you're going to do is factor out a -1 in order to get you the positive 160. And I like to do my prime factors like this because it keeps them in order, and that's just neat. It keeps them neat and in numerical order. So I'm going to divide that by 2 and I get 80. Divide by 2, I get 40. Divide that by 2, I get 20. Divide that by 2, I get 10. Divide that by 2, I get 5. Once you get done with a prime number, you're done. So make sure you write these out, including the -1. So we're going to have -1 times 2 times 2 times 2 times 2 times 2 times the 5. In number 2, the prime factors of 45 are 3 times 3 times 5. And then you have x squared, so write that out twice, and then the y to the third. And those are your prime factors there. And the reason why we want to do that is because in number 3, we have 45 and 36. Well, the prime factors of 45, we just said were 3 times 3 times 5. For 36, I get 2 times 2 times 3 times 3. So the GCF would be what's in common, I guess, right? So we have a 3 in common, and we have another 3 in common. So the GCF, the greatest common factor here, would be 9. In number 4, we have 120, x to the third y. So let's take the 120 and let's try to find the prime factors. So let's come up here someplace out of the way, and we divide that by 2, we get 60. Divide that by 2, you get 30. 2, you get 15, and 3, you get 5. So 120 x to the third y is equal to 2 times 2 times 2 times 3 times 5. Don't forget your 3x's and your y. And then you have -96 xy squared. Let's try the 96. We're going to divide that by 2, you get 48. Divide that by 2, you get 24. Divide that by 2, you get 12. Divide that by 2, you get 6. And 2, you get 3. So don't forget the negative here. So we're going to have, for -96 xy squared, we're going to have -1 times 2 times 2 times 2 times 2 times 2 times 3, x and 2 y's. Now, what's in common? Well, we have a 2 in common. And we have a second 2 in common, yet another one. We have a 3 in common. We have an x in common. And we have a single y in common. So the greatest common factor would be 2 times 2 is 4, times 2 is 8, times 3 is 24, 24 x, y. In number 5, 6, 9, and 8, what's in common? 1. Do we have any variables in common? Well, I'd have to have a y in all 3 of them. I don't in the last one. I would need to have an x in all 3 of them. I don't in the first one. So my GCF here is 1. Now remember, when we're factoring polynomials, that one of 3 things is going to happen. First thing you always look for is what? Right, a GCF. But then after that, it could be in the form of x squared plus bx plus c, ax squared plus bx plus c, or it could be a difference of 2 squares. Well, what do we have in number 6? X squared plus bx plus c, where we need to break this down into 2 binomials. X times x will get us the x squared. Remember the golden rule. Whatever number you put here times whatever number you put here has to equal -6. And there's only one way you can get a negative out of that, is if one is positive and one is negative. Well, what factors of 6 do I need? Well, if I put a 3 here and a 2 here, I'll get 3x here minus 2x here, and that'll give me your 1x that we have in the middle. In number 7, I'm going to break up the x squared into x times x. I need two numbers that when you multiply them together, you get positive 24. Since it's positive, the two signs have to be what? The same. They will both be minuses, 6 and 4. 4c squared minus 25, what does that fit under up here? 1, 2, 3, or 4? Well, it's a difference of two squares, number 4. But is there a GCF first? No, there's not. Break it up into the two parentheses. The square root of 4c squared is 2c, so I put it here and here. The square root of 25 is 5, so you put that here and here. 1's plus and 1's minus. In number 9, is there anything in common here? Yes, there is. There is a 3 in common, so we factor that out. Now, once you factor the GCF, what will it look like? Well, you're going to need, remember, 3 terms inside the parentheses. It'll be b squared plus 14b plus 49. Now, can this be factored again? Yes, it can. We're going to get b plus 7, b plus 7. Don't forget to bring down the 3, and now you're done. In number 10, this is factored by grouping. Remember, if there are 4 terms, we're going to group the first 2 together and the last 2 together and see if we have a GCF here. We do in the first term, we have x, and that'll be x times the quantity, x minus 3. And then we're going to factor out a 5 out of the second set of parentheses. We get 5 times the quantity x plus 3. Now, in order for these two to be, in order for us to continue factoring this any further, we need to make sure that these two parentheses are the same. They're not. It can't be factored, so we would say this one's prime. Z to the 4th minus 1. This is a difference of two squares. Remember, 1 is a perfect square. You got to remember that. And then anytime you have an even exponent, you have a perfect square. So z to the 4th minus 1 is a difference of two squares. So how are we going to break that up? Well, we need two sets of parentheses. Z squared and z squared, square roots of z to the 4th. 1 and 1, square root of 1. 1's plus and 1's minus. But, and at first thought you might think that we're done here, but we're not, because this z squared minus 1 is a difference of two squares again. It can be factored into two sets of parentheses. Square root of z squared is z. The square root of 1 again is 1. 1's plus and 1's minus. This one cannot be factored again, so we just bring it down. We get z squared plus 1 times the quantity z plus 1, z minus 1. Let's go to the next page. In number 12, 2x squared minus x minus 15. That one fits the ax squared plus bx plus c format, and what we're going to do is break up the 2x squared into 2x times x. Then I need factors of negative 15, which means the two signs are going to be different. But because I have a 2 here in the first spot and a 1x in the second spot, I don't know which one's going to be the plus and which one's going to be the minus. But this process, what we taught in class, was guess and check, right? So let's guess as to what one of the answers would be and see if we're right or not. Well, if I put a 5 here and a 3 here, 5 times 3 being 15, right? Well, if I put minus here and plus here, what will that give me? That'll get me minus 5x. This will give me plus 6x. And that'll give me positive 1x in the middle, doesn't it? Is that what we want? No, we want minus 1x. So if I have the wrong sign here, that means I have the wrong signs here. So let's make this the plus, this the minus, and that should work out. That'll give me the plus 5x, that'll give me minus 6x, and now I have it factored correctly. In number 13, what are you going to do first? Well, what I would do is look for a GCF. Do we have one? Looks like it. So I'm going to have 2 times the quantity, 3x squared, plus 8x plus 4. Now, I need to know, can this thing be factored again? How do you know? Remember what we did? Is we would take 3 times 4 and get 12. Now, do I have factors of 12 that add up to 8? Well, 1 and 12, 2 and 6. Oh, there it is, 2 and 6. So yes, this can be factored again. So I break the 3x squared plus 8x plus 4 into 2 parentheses. You know what I'm going to do? Simply because it's 4, I'm just going to use, we know there are going to be pluses, right? I'm just going to try 2 here and see if that works. 2x plus 6x is 8x. There we go. Bring down the 2 and you're done. In number 14, we have 4 terms. Factor by grouping. Group the first 2 together, group the second 2 together, and factor out the GCF out of each one. Here we have a 4x. So I'm going to have 4x times the quantity, x minus 2. I'm going to factor a 13 out of the second group. I'm going to have plus 13x minus 2. And look, this x minus 2 is the same as this one. So I'm going to bring it down. What will you have left over once you bring that down? The 4x plus 13 goes in the other parentheses. Number 15, 9x squared minus 27x plus 14. I'm looking for a GCF, and I don't have one. So it looks like don't just be thinking it's prime because you're going to give up on it. Break that 9x squared up. Try 3x times 3x. See what happens. Now, since this is a plus sign here, we know the 2 signs have to be what? Well, they have to be the same, and they're both going to be minuses. Because remember, this number times this number has to give me positive 14. There's only one way to do that is by multiplying 2 signs that are the same. Well, I'm going to try 7 and 2 just to see if it works, because that'll give me the 14 at the end. Here I get negative 21x. Here I get my negative 6x. Looks like I got it on the first guess. What do we want to do in number 16? Well, we could factor it just like it is right here, but I am going to write this in descending powers just to get it into the form that we're used to seeing. And now I need x times x to get me x squared. I have 2 plus signs. Let's see now, what would it be? 40 and 1, 20 and 2. How about 10 and 4? That'll get me the 14x in the middle. Number 17 is a difference of 2 squares, but remember, what are you supposed to look for first? There is a greatest common factor here of 25. So I'm going to have 25 times the quantity. How many terms inside? 2. X squared minus 4y squared. Do you think you're done? Or can you factor this one further? Well, seeing that this is a difference of 2 squares, it's going to take 2 sets of parentheses. The square root of x squared is x. The square root of 4y squared is 2y. 1's plus, 1's minus. Bring down your 25, and now you're done. Number 18, do you have a GCF? No, you do not. Since you don't, and again, don't be giving up on me here, know that you're probably going to break up the 15x into what 2 factors? Well, it's guess and check, so we may as well guess 3x and 5x, right? Now, if I use 5x and 3x here, what is it about this problem? If I'm going to break up the 10, let's say I'm going to guess 2 and 5 here. What is it? Why is it I know I cannot put the 5 here and the 2 here? Even before I start multiplying and guessing and checking and all that, I just know off the bat I can't put a 5 there. Well, that's because in our original problem, we said that there was no GCF. And if I put a 5 here, I would be creating a GCF with 5x and 5. So that can't happen. So I know the 5 cannot go there. But if I am going to guess the 2 and the 5, let's go ahead and do that. With the 2 and the 5 here, what else do I need, though? I need a y times y to get the y squared. Now, let's do the top part of FOIL. 5x times 3x is my 15x squared. 2y times the 5y is 10y squared. My 2 signs have to be minus and minus. will I get negative 31xy in the middle? Well, let's see. Here's negative 6xy. This one is negative 25xy, and that gives me my negative 31xy in the middle. So we've factored that one successfully. N squared plus 16, how is that going to get factored? Let's go back to the first page. Does that fit any of these four? Is there a GCF, x squared plus 16? No. Otherwise, does it fit any of the rest of the three patterns there? No, it does not, because of the what? That's right, the plus sign. That makes this prime cannot be factored. All right, 20 is 27x to the third y plus 75x to the fourth y to the fourth minus 3xy. Oh my goodness, this looks huge. One bite at a time. Ignore the variables for just a second here. Look at 27, 75, and 3. Isn't there 3 in common? All right, so let's divide that out. Now look at your x's. You have x to the third, x to the fourth, and an x. Remember, what is it about the exponents? Pick the smallest exponent, x. Now we have y, y to the fourth, and y. Again, the smallest exponent. So we just have y to the first here. What's it going to look like? Well, 3xy on the outside. Your GCF is on the outside, and however many terms you're starting with, remember that's how many terms you need to end with. So inside the parentheses, we're going to need 3 terms here. 27 over 3 is 9. X to the third over x is x squared. The y's cancel. Plus 75 over 3 is 25. X to the fourth over x is x to the third. Y to the fourth over y is y to the third. Minus, these cancel. So I have minus nothing. No, we know better than that, right? Minus 1. X squared minus 3x minus 4. I know I need to start with x times x. And I need both signs the same. Look at this. That's a plus sign, right? Whatever number I put here times whatever number I put here has to give me a positive. Both of them have to be negatives, right? So it's either going to be 4 and 1, or it's going to be x minus 2 and x minus 2. We cannot put x minus 4, x plus 1. Why is that not an option? Because negative 4 times positive 1 is negative 4. We need it to be positive 4. So that's not even an option. Our only 2 options are these. Which one gives you a middle term of negative 3x? Neither one. Prime. V squared plus 9v minus 52. Well, we're going to start with v times v. I know my signs have to be different, so plus and minus. This says I need more pluses, so my bigger factor needs to be positive. How about 13 and 4? Doesn't that work? 13v minus 4v. Doesn't it give you 9v in the middle? So v plus 13v minus 4. And last but not least, number 23, 7t squared plus 44t plus 12. Let's see now. I know it's going to be 2 parentheses. I don't have a GCF here, right? 7, 44, and 12. The only way to break up a 7t squared is going 7t times t. Let's see now. I need factors of 12. My first thought is 4 times 3 is going to give me 12. But remember, whatever I put here, I need to multiply it times 7, and we need to get all the way up to 44. So if I put a 4 here and a 3 here, 7 times 4 is 28, plus 3 is, 31. So that's not going to work. What other factors do you think might work here? How about 2 times 6? Now, if I put the 6 here and the 2 here, now they both have to be plus signs, right? So I'm going to have 2t here. It looks like this might work. 42t here, and we get 44t in the middle. So there's your answer for number 23. Let's talk some more about any other questions you might have on the review, and let's get that taken care of before we take the test, okay? Have a good day. I'll see you guys in class.